Out there, 155 light-years from Earth, a young star glows in the dark. It's not special at first glance, not too big, not too small, not too different from our own sun. But circling that star is a message, not a signal, not a sound, but a signature, one that's been waiting for us to understand it for decades. This is the story of HD 181327 and how the James Webb Space Telescope just uncovered one of the most significant clues in the search for life beyond Earth. Crystalline water ice, frozen, fragile, and scattered across an alien solar system. For years, scientists suspected it. Hints in the data, whispers from retired telescopes like Spitzer. But until now, no confirmation. No clear proof that water ice, solid, structured, life-giving, could form and survive in other star systems. Then Webb looked, and the universe blinked back. Webb didn't just detect ice. It detected crystalline water ice, the kind you find in Saturn's rings or in the icy rubble of the Kuiper Belt. This isn't random frost. This is structured, reflective, deliberate ice. It tells us something important. The conditions to form it are specific. They need cold, calm time and collisions. But HE 181327, it's a young system, just 23 million years old. The Sun was still forming planets at that age. Around this star is a debris disk buzzing with action. Rock, dust, ice, all crashing into each other. Smashing, fragmenting, rebuilding. These collisions eject tiny icy particles perfectly sized for Webb's ultra-sensitive instruments to detect. And what they saw? Over 20% of the outer disk is made of water ice. That's huge. Let me ask you something. If frozen water is this common out there, how many Earth-like planets could be hiding in plain sight? Drop your theories in the comments. If you're enjoying this cosmic dive into the unknown, make sure to subscribe and tap the bell. Webb's observations show that ice isn't evenly spread. The farther out you go, the colder it gets and the more ice you find. Move closer to the star, the ice drops to just 8%. Get too close, it disappears altogether. Why? Because the star's ultraviolet light vaporizes it. Or, some believe, it may be locked away in larger rocky bodies we can't yet detect. That's the beautiful thing about systems like this. They're both familiar and foreign. Like a memory of our own solar system, seen through the lens of deep time. 4.6 billion years ago, our Kuiper Belt may have looked just like this one. Crashing icy bodies, dust swirling around. A system in chaos, but rich with potential. Water ice is more than a mineral. It's a carrier of chemistry. Sticks to rocks, ferries carbon, forms comets, and it might be the reason Earth even has oceans. That's why this discovery matters, because in these distant frozen clouds, we're not just seeing ice, we're seeing the raw ingredients for planets, for oceans, for life. So what comes next with Webb? We're just beginning to map the icy footprints of planet formation across the galaxy. Every discovery like this tells us more. Where to look, what to look for, and just maybe, how common life might really be. So next time you look up and wonder if we're alone, remember HD 181327. Remember the icy dust glittering in the dark. And remember, the universe is writing its story in frozen water, and we've finally started to read it. Subscribe for more discoveries that will make you rethink the cosmos. Leave a comment. What do you think Webb will find next? And as always, stay curious, because out there something amazing is always waiting.